I'd like to talk to you a little bit about surface transforms this evening. We are a UK SME and we're a manufacturer of carbon ceramic brakes. The markets we operate in, you can see a picture on the front cover there, is the automotive luxury performance car market, and we make the brake disc that fits inside the wheel, and I will explain a little bit about the engineering and technology there as well as part of the presentation. As a bit of history, and potted history at that, we've been around for a little over 15 years on AIM, and we've been spending all of that time, if I'm brutally honest, doing all of our engineering, advanced engineering, and developing our product and developing the business. I think the story I'm going to tell you today is about how that has all come of age in the last sort of 12-18 months, and how the business is now on a different track than what it was before. And a part of that is we've been announcing contracts over the last sort of 12-13 months worth about 43 million in lifetime value. There's been 4 contracts announced in that period, and they really have been transformational for the business, and have really put the business on a different footing, not only now but in the future. And again, I'll give you a bit more of the detail as we go through. I won't spend a lot of time on this. Roland's already gone through a disclaimer, so we're no different from ourselves. Okay, brief introduction first of all about automotive brake discs. Every car has a brake system. That brake system is safety critical. It's used to slow down the car, and the engine is used to speed it up. Every car's actuation is done normally by the foot of the driver, and I've put a little red box around the wheels there, and that actuation of the pedal tends to activate and squeeze the brake inside the wheel, and there are 4 of these inside the 4 wheels of the car. Now, looking on the right hand side there's a bit of a bigger picture. Inside there are a number of components, and it's those components, as I say, that when you use it retard the speed, and is absolutely the critical feature, and also a performance feature of the car. So when you want to drive the car spiritually, you can, and when you want to stop it in an emergency environment, you can also. How does a brake work? Well, I've got a picture here of how the system is built up. There are 3 components, and the first component is the brake disc. That rotates inside the wheel, and it's the bit we're going to be most interested in. But the actuation of the brake is done by a caliper, this red piece in the middle here, and 2 brake pads slot inside the caliper, and then when you press the brake inside the car, it squeezes the brake pads against the face of the brake disc, creating a frictional force, and it's that frictional force that slows the car down on the road. Now, we're very interested in the brake disc, and the picture here, every car, as I say, has a brake disc in every corner of every corner, and it's usually made of grey cast iron, and there are literally hundreds of millions of discs made for all cars in the world today. Now, we're not interested in the main market, we're interested in the luxury performance market, so it's a little bit more sheltered than the normal automotive market. And in that market, where we operate in a business where you can replace this aging technology of iron rotors with a carbon ceramic brake disc and get a much better performance and feel, and lots of things that are very good for the vehicle manufacturers and the end user. If I go through some of those drivers that is driving and making a compelling case for why vehicle manufacturers are swapping out their grey cast iron discs and putting ceramics on and selling it to the market, the first one is technology. Cars have got heavier and faster over the last 20-30 years. As they get heavier and faster, they effectively generate lots more energy as kinetic energy and speed, and to stop a car, you're really converting that kinetic energy into heat. That's the job of the brake. And what you find is that energy can exceed the capability of iron rotors. And at that point, you start to lose the brake efficiency, you lose friction, and you actually start to lose the braking power in the car, which is obviously undesirable and unwanted. By swapping out the iron rotor for a ceramic, you can eliminate that issue altogether, and you never have to you'll never exceed the capability of a ceramic brake on a car. Secondly, they are lightweight. So comparing the weight of an iron rotor to a ceramic, it's about half the weight. When you swap out all four corners of a car, we talk about saving about 25 kilos of weight. Now, weight is very important in terms of cars today. And not only can you save 25 kilos, if you swap out all of the other components that are holding the brake system in place inside the wheel, we talk about a multiplying effect and a weight saving of up to 100 kilos. Now, 100 kilos equates to about 5% of a car's weight. And why does that become important? It's really to do with the efficiency of the car in terms of its fuel consumption and CO2. And I'll talk about that in a moment. So that weight saving, as I say, means you can reduce your CO2 emissions, incredibly important for combustion cars today, not so important for electric cars. But on electric cars, interestingly, one of the other features we'll talk about, and I'll pick it up as part of this presentation, is it's very good news to have weight saving because they're all focused on range and extending the range of a car. So rather than reducing the emissions with weight savings, you can extend the range of electric vehicles. Not only that, from an environmental perspective, one of the main issues that comes from actuation of brakes is brake dust. If you talk about what's bad for the environment and particulates in the air, we instantly talk about car emissions from the engine. That's improving and coming down, and obviously with electric vehicles, they're eliminating that. The next big issue will be brake particulate dust in the air, and also when it gets laid on the road, it gets washed into river systems and water systems and can cause issues from the environment in that regard as well. Now, going from an iron brake to a ceramic, you effectively reduce the amount of brake dust generated by half, and therefore reduce the amount of pollution and the environmental effect. We talk about ceramic brakes are significantly more expensive than an iron rotor when you first purchase them, but we talk about the lifetime cost and the total cost of ownership. Now, ceramics will last the lifetime of a car, whereas an iron rotor you typically replace every 30, 40,000 miles. So over the lifetime of a car, you might have 3, 4, 5 sets of brakes on it. When you multiply the cost of the brakes and the cost of servicing and the downtime for the car and compare that total cost to the cost of the investment in ceramic, it's quite favorable for purchasing a ceramic up front. In terms of quality, and here I talk about the benefits again of weight saving, because the markets we operate in are the performance luxury car markets. Some of the key features of the car, like the handling, the refinement, the comfort, the feel of the car, can be influenced significantly by weight saving. And that's no different from adding a ceramic brake. For the luxury car market, having a very heavy weight inside the wheels, which is hanging off the chassis and needs springs and suspension systems, you can reduce the impact of bumpy roads, noise, refinement. And for sports cars, performance cars, the gyroscopic effect of having to turn corners and pull weight out of a straight line around a corner, you get a massive benefit from reducing the weight of the unsprung mass inside the wheel and improve the handling. From an aesthetics point of view, they're highly desirable. They look like a mirror inside the wheel, so they become very glossy and shiny when in use. They don't corrode compared to an iron rotor. And as I've mentioned earlier, with less brake dust, you get cleaner wheels. And the vehicle manufacturers are very focused on, one of the complaints they get a lot of the time is that the wheels in the car gets dirty too quickly from brake dust. So that's very desirable. And they're instantly recognizable as a high-tech premium product because they're accompanied usually by a very bright caliper. I showed you a very bright red one early on in the introduction. Typically they might be banana yellow, so people can instantly recognize when a car's got a ceramic brake on. And the last key component to the market drivers is it's very unusual, particularly in the automotive market, to have a monopolistic supplier. That's been the case for the last 10 years, effectively, with a company called Brembo SGL being the only player. They have revenues currently of about 160 million per year, and the market has been very keen and has been working with us for at least 5 years, 6 years to pull us through as a credible alternative. And I think as I talk about how the progress we've made in terms of contracts, that's now occurred, and the market now can start to have some competition. Competition allows markets to grow, allows capacity to be built, and that's an integral part of how we see the future. Now, it's putting all those market drivers together that I've seen all of those guys I've just put up on the screen there, those manufacturers, see them adopt ceramic brakes and start to continually select them for their premium car platforms going forward. And we'd expect that list to grow. Indeed, there are some names on there that I haven't put on that now do use carbon ceramic brakes, and this market will grow from here, and it's a substantial market, which I'll explain in a moment. Now, if I talk about where the value in our business is for shareholders and effectively the value for our customers, I'd like to start with the product first of all. And here I'm comparing our product, our carbon ceramic brake product, to our competitors rather than to the market incumbent, which we're replacing, the iron rotor. And when I compare our product to our competitor's product, we talk about our technology being superior. In essence, the brakes are made of the same chemical elements. They're made of carbon and silicon. However, it's how you put those together. And the analogy we use here is you can get different types of wood. They're all pieces of wood, but they're made differently. And we make plywood, and our competitor makes chipboard. Now, they both have a place, but they give you different properties. And so we talk about our technology and products having better heat management. And remember, brakes are all about converting kinetic energy into heat. So managing that heat is critically important. And we talk about the long fibers that we put into our material give us a much higher lifetime than our competitors. This is a competitive market now with ourselves coming into it. Price is important to our customers. It's fair to say we are competitive to our competitor, Brembo SGL, and that's comparing even at scale. Obviously, there's a difference in scale between ourselves as a small player in the market today versus Brembo at 160 million. But prices wise, we're competitive. We've worked hard on our manufacturing process, and we can talk about very confidently about achieving good margins. And by good margins, I mean typically our gross margins, if you were to look at our numbers, are in the region of about 65 to 70. We'd expect to maintain those going forward as we grow and maintain at least above 60%. A key driver for us and our customers is capacity. We've invested significantly in the capacity of the business over the last 3 to 4 years. We now talk about having an installed capacity of circa 20 million per year. And the other key feature of our facility is that capacity is being built as a modular cellular plant. And we have a very large footprint at our facility up in Liverpool. And the way we look to expand will be to replicate that cell and build, we call it OEM cell 1. As we go forward, we'll have OEM cell 2, 3, 4, and 5. So we talk about our facility being expandable, and we think we can put another 4 cells in there. So we talk about our being able to grow our revenue quite rapidly by installing new capacity. From a quality perspective, it's a given, if you like, from a safety critical and automotive standpoint, that we are certified to the key standards. We've been certified for at least the last 5 years to the industry standard. The automotive one's called IATF 16949. We're also ISO 9000, and we have our environmental certifications as well with 14001. So that's a bit like achieving your driver's license to be able to drive fully or something along those lines. Key markets for us in terms of geography are the UK. As I say, we're based up in Liverpool, so we can look after the UK from our headquarters. Germany, we have a very small sales office in Germany to support the German market, and the US as well. And the last key feature, if you like, from a value proposition point of view, is the supply chain. As I say, we've spent the last 5+ years developing our credibility as the alternative, and part of that credibility is about having an independent, well-developed supply chain. And we've now got that. We dual source most of our materials and inputs into the manufacturing process, and we actually have a very highly integrated process that takes raw materials fiber and takes it right through to the finished component that ends up on the car. How does that all build together in terms of an investment proposition? Well, I mentioned earlier we've been very fortunate to have announced 4 contracts in the last 12-13 months, totaling about 43 million in lifetime revenues. How do they pan out? I'll give you a bit more detail in terms of our revenue roadmap, but the top level here is our revenues for our calendar year FY 2020 are 2 million, and we'll see rapid growth with our existing current contracts, and we'll enter profitability in 21 for FY 21 at 7 million. And when we see the full effect of those contracts, which only really give us half or a little under half a year's contribution in 21, when we see the full 22 effect, that'll grow our revenues to just over 12 million per annum. Now, that is also in the context that once we've engineered these products with most of our customers, the expectation our customers have is that they only want to invest in the engineering once, and then they want to be able to utilize that going forward. So we have a prospective contract pipeline over the next 5 years, 50 million per annum. And most of that 50 million, not all of it, is with existing customers on future platforms and car models. And of course, there are new customers and new OEMs testing our product as well, which we don't talk about until we've won a contract, but they are in that pipeline. So that's where our 50 million and our growth over the next 5 years is going to come from. And of course, that's in the context of when we look at the overall addressable market, we see a £2 billion market, which is made up of cars above 50 to 75,000 retail price will eventually swap out one main braking axle on the car, and cars above 75,000 will be able to swap out both axles on the car and swap out all 4 corners. When you add up those and then times it by a future selling price, we get to a £2 billion per annum market. So a lot to go at. Now, if I just take a little bit of time to talk through that revenue roadmap and the contracts we've been winning. We sent out a trading update quite recently on 2020, and 2020 has been an interesting year because of COVID. We expected 2 things to happen. We expected a downturn in our revenues for our existing customers, near OEMs we call them. They're small car manufacturers, typically somebody you might not have heard of, but would make 50 or so for 100 cars a year, and retrofit customers who already have their car and want to upgrade it to the best brakes in the world and will invest in a new set of brakes for their existing car. We expected a downturn there, but we're pleased to say it didn't materialize. So we talk about increasing our revenues for 2020 rather than holding them the same. But we also expected one of our contracts with Aston Martin Valkyrie. We expected that to be delayed, and we've seen that come to fruition with the COVID pandemic, and we'll expect that series supply for Aston Martin Valkyrie to begin in 21. Now, I'd like to talk a little bit about the new contracts there, and I'm going to talk a little bit about OEM 8, but before I get onto that one, we have also announced a new contract with an OEM 5, and you'll see I'm talking about numbers here rather than customers. Our customers are very precious about managing the market and the PR, if you like, about introducing some incredible technology on their cars. So they don't like us talking about it until they have. So as part of that, we give them a code name until they announce it. So Aston Martin very kindly announced that we were on their car some time ago, and as we go through with OEM 5, 6, 7, 8 and so on, we will be able to talk about them by name, but not right now. Now, OEM 5's contract we announced, it's on a car which has the one braking axle, will be equipped with ceramic, so it's in that sort of 50, 75,000 pound price range. And we've been doing the engineering work throughout this year. That's going well. Contract starts towards the end of 2021 with startup production. It's worth about 1.8 million to us per annum, and some of that will go on for many, many years to come. Koenigsegg, another OEM we work with, we've announced 2 contracts with them recently. One being for their next platform, which starts in 21, called the Jesko, and another one in 22 called the Chimera. And that'll the Jesko will start production very soon into 2021. And then we announced our biggest contract to date a few weeks ago with OEM 8. OEM 8 is another global player in the automotive market, similar to OEM 5. We've been selected as the sole supplier as a standard fit, whereas the model we're on with OEM 5 is an option. And again, that goes into production in 2021. So I think there's a theme here that says all of our contracts are now in place, these existing contracts. They're all being worked through. There's some development revenues we see now, and they all start to make a significant contribution to revenues in 21 in terms of start of production. Now, the run-up rate for OEM 8, once it gets up to full production, is about 8 million per year, and the total lifetime value for that contract was a little over 27. And as I say, one of the key things about these contracts with the likes of Aston, OEM 5, Koenigsegg, and OEM 8, and new customers as well, is that we do the engineering for the first platform, and then we become an approved part, or another phrase you'll hear us use is we'll be put in the parts bin. And that means the OEM can, when they're looking at their next model and subsequent future models and planning for those, they look to their approved parts and parts bin to be able to pull something off that bin and then put it straight on the car, reducing the development costs, reducing the risks, and allowing them to introduce technology across the range rather than just on one first model. And we'd expect that with OEM 8, we expect it with OEM 5, and it forms a significant part of our contract pipeline, which we see at 50 million over the next 5 years. Now, in terms of those contracts, as I say, they've totaled about 43 million in the last sort of 12, 13 months. So it really has been a transformational period for us as a business, and we see that continuing. And what it means for us as well is internally for a business, we're making, if you like, further additional investment in our teams, and we're strengthening the teams in depth. We're bringing in some new engineering personnel, some new quality personnel, some new purchasing, some production staff, and we'll see that add progressively. So what I mean by progressively, 2 million to our overhead is it'll add about 500,000 in 2020, it'll add 1.3 million in 21, and then we'll become a mature 2 million to our overhead in 2022 onwards. And that really is to support all these existing contracts that we now have in place, and to support that very exciting contract pipeline we have as well. Now, the other feature we need to consider is capacity. As I say, we have 20 million of installed capacity currently. We think that's about 60% full now, but a feature of the business is it's expandable in our current facility in Liverpool, and we can add the new cells and modules as and when we win contracts. And typically a cell takes us about 18 months to build. It's in the region of 7 to 10 million as an investment. And it's important to understand how the industry works. We would normally have sight and be awarded a contract 2 to 2.5 years before series production. So it's our intention going forward that as we win contracts, we can do our capacity planning based on contract wins, the size of those contracts, and the timing of when they start production. So for 2021, it brings profitability with OEM 8's contract and all the others. And the other key feature is we have a very good visibility of those revenues going out because they're recurring revenues with multi-year contracts in place. And I put the years up there. Valkyrie is quite a short one, but the others go out past 2024, 2027, and 2029. Now, just touching very briefly on, as I say, the growth that would take us from 2 million this year to 7, and then into 2022, where we talk about north of 12 million. That's simply because we only talk about our existing contracts. We don't build in what we think we might win, but we're seeing that growth because those existing contracts give us a full year, and that full year drives the revenues, nearly doubles those revenues again from 21 to 22. And as I say, for the future, we're very excited about what we see as a contract pipeline over the next 5 years. It comes to circa 50 million. And we've tried to break that down in terms of existing customers. OEM 1 I don't talk about a lot. We've had contracts with OEM 1 that have finished. We're expecting there's potential with those going forward of 10,000 discs per year. OEM 5 slightly more, some with OEM 6, and OEM 8 makes a significant contribution to that green bar I've got there of 30,000 a year. And the rest is with new OEM customers, which there are numerous ones we're working with. Okay, if I can just then summarize what I've tried to explain about the business, we think we're a very exciting investment proposition. We've got a very strong position in our chosen marketplace, and that's marketplace that has a potential £2 billion per annum revenue market. It's got a prospective pipeline of 50 million for us over the next 5 years, and that pipeline is spread across a significant number of our existing customers, known as OEM 1, 3, 5, 6, 8, and so on, and some new OEMs which we don't talk about until we've been successful in landing a contract. The latest one we landed with OEM 8, a truly game-changing contract for us, with sole supply, beating off our competitors with standard fit and going into production in 21. It starts to fill up our capacity. We've got some headroom there for new contracts as they come in. We're making that new investment in supporting those contracts with strengthening the team and putting us in good shape for the future prospects. And we'd expect to be announcing new contracts going forward. And really, that leads me to the last point about our revenue roadmap. Is now fully in place, bringing us into profitability in 21. Those revenues are recurring with all of those existing contracts for multi-years. So it gives us a good visibility going out at least 4, in some cases 9 years. And of course, we've got our, if you like, foundations, which we've been using for the last number of years with our near OEM customers and retrofit customers, which have been holding up very well during this COVID pandemic period. So that just leaves me, I think, to thank you all for listening, and I'd love to hear what questions you've got.
And I've had one here, which I think was fantastic. It kind of covers a few things together. A lot of questions about competitors.
Yep.
How come there's only been one major competitor for such a long time? What are the barriers to entry with others with ceramic brake technology?
Well, I'll answer that with our own journey, if that makes sense. So we might appear as though we're being very successful now, but we are, this idea that we're an overnight success is simply not true. We've spent the last 10 years plus completing all the advanced engineering that our customers would need. We've completed millions of miles on the road. It's a very complex manufacturing process with a huge amount of know-how in there, and that ultimately is the barrier to entry that has seen, if you like, one competitor there, and to ask a company, if you like, or to ask from an investment proposition to say it's going to take 10 years, your customers are going to want you to complete exhaustive testing, invest an awful lot of time and money in doing so, means the barrier to entry is simply that, and it's a huge one. But once you're in, and once you've got over that line, as you could probably tell, our competitors had the luxury of having a monopolistic position. The market needs 2 players, and the barriers are the same for anyone else to join. So we're now pleased to have got over that barrier, if that makes sense, but it is a big one.
Just the thoughts I had. Do you tend the new contract wins? Some I think probably new models. Are they all new models, or do manufacturers, OEMs, ever change a supplier partway through a model's life?
Yeah, good question. They would always be new models. It's just it's a feature and a entry. So you would never go back and put it on an existing model. The cost to do that is just so great for the vehicle manufacturer that it's just not economical for them. So once you start winning contracts, you're on that car for the life of it, which is why it goes on for 4, 5, 7 years or so on. So again, you could also argue that the barrier to entry is you've got to wait for those new models to come along, if you like, and then you can get on them. So nobody does a retrofit, if you know what I mean, as a vehicle manufacturer. They just have a product planning schedule that says we will be launching these models, and typically they launch one every year, 9 months. They like to be launching new models all the time, and that's the opportunity to get your product on that car for the lifetime of the car.
And I had someone wanting clarity. Are the contracts for optional fit with cast iron as standard, or for 100% standard carbon discs? I think you did address one of those, or two of them in your comments.
The answer's it's a mixture. So depending on the model, depending on where the customer wants it to be, some of our contracts, the OEM contract 5 is for an option. So we know they know what their take rates are, so they know how the volumes will, if you like, be taken up. For OEM 8, for Aston and Koenigsegg, they're all standard fit, and they'll continue to be a mixture of those going forward. And what tends to happen is for some of those smaller volume cars, they'll put it on standard fit, the more expensive ones, and as that moves through their range, they'll put it on options on on other cars. So a good example is the OEM5. That's the lowest price car we actually do, if that makes sense, and it retails for about 70 odd thousand. And at that range, currently, it's an option for those types of cars.
A few questions on Brexit. Our friend, how will you be affected if there's a no deal Brexit? And are you forecasting any Brexit risks for the market from material supply?
Yeah, so yeah, I used to answer this question a lot. I haven't answered it for a while, but the answer hasn't changed. Look, if we have to, we would trade under the WTO rules, and there is a small duty of about 4%, and so we're not concerned about that 4%. We've done all of our planning in terms of trading with Europe at a significantly higher exchange rate a couple of 2 or 3 years ago, and we've seen the exchange rate go in our favour by more than that 4%. So it's more than offset. We'd be more worried about frictionless or friction borders. And as I say, if we're working with our German OEMs, we have a presence in Germany. Our plan has always been that if we needed to increase that presence in Germany, we would, and it would become a staging post. So the last part of our process is the final assembly. It's a very simple process. We may well look at doing that final assembly in Europe to deal with any Brexit issues. But that said, we're not just exporting to Europe. Our customers, even if they're European based, they are getting us to export across the world. So a good example is we won't be, one of our customers in Germany doesn't want all of the product to be brought into Europe. They want it sent to other parts of the world where they've also got assembly plants. So it isn't as big an effect as you would imagine. We're well prepared for it. We just wait and see what happens.
Okay, and I'll read this one out so I get the correct terms. To use your analogy, does it not cost more to make plywood compared to chipboard? Your competitor just seems to tip chopped fibre into the mould, so I presume more care is needed of your continuous fibre.
Well, the simple answer is it doesn't cost any more. And let me explain why that might be. Fundamentally, although they're tipping it in, they're still having to complete a significant number of processes, which typically cost the same as us. So the raw materials are the same. Machining is another key component. That is the same for both types of technology, and the other things that go in there like fiber and silicon. The costs of those are similar as well. So that really the inputs that go into the two discs, there is no competitive advantage for either. Now, that said, the equipment used is different. So pouring it into a mold versus us knitting it together in long fibers is different. However, I am aware that we believe we have a competitive advantage over Brembo SGL on the cost of the equipment and the cost of capital. So the investment cost to build capacity, we believe we're more competitive than they are at that. So as much as I say we are competitive, we might have a slight advantage there, but the fundamental things that go in there are the same. The other big one is power, of course, and power is a utility rather than anything else.
We are a little bit over time, but I just want to have one more question, if I may.
Yeah.
And it's about IP protection for that. Is that process protected?
Well, we do have some patents, but I think that would be misleading for me to say that the patents protect us. That's not what we're about. Our proprietary technology is in the know-how. We have about 30 different processes to make the disc. As I say, it's a major barrier to entry for anyone wanting to do this. That the combinations, it can't be reverse engineered, so you can't take our product and pick it apart and work out what we've done. And the know-how, when you work it out, it is a staggering number of millions of combinations of process parameters that really matter. That you get one wrong, you change the temperature of one of the furnaces by 5 degrees, and you won't get the right product. So our technology and our proprietary processes are our protection.
Okay, thank you. Well, I've had one here which I think is interesting. Just a quickie. Is Formula One a potential market or a market for you?
No.
No, fine.
Not
There we are.
interested.
Lovely. Kevin, thank you very much indeed for joining us.
You're very
Excellent.
welcome.